So we started off this one, and I had meant, okay, so this is actually when they say the P of X, and it's also representing the percentage. Because percentage is out of 100, when we talk about half the students in the lecture, that means this is 50%, and that means that the P of X, instead of the 1/2, needs to be 50. And that went through me because of the fact that we're talking about 50%. Usually you take percents and change them into a decimal, and that's kind of what my thought was on this, and that's how we'll also plan on that for the half-life. But in this case, they've got it set up where this is more of a percentage here. So this is going to change to then 50%. Then when I go back here, and I'll take out this one and this one, and this, let's just do all of these. And I'll have to have my calculator. So the very first thing we're going to start off with, we're going to still move the 95 to the other side. So I'm going to go 50 minus 95. So I'll have 50 minus 95, and that's going to give me a negative 45. Then I'm going to end at 30, negative 30. So I'll divide by negative 30, and I get the 5. Now, in this case, I'm going to go ahead and then change this to, I have a base of 2, so it's going to be 2 to the 1.5 power is going to equal x. And so then I would go to, my caret function is right up here, that makes it at the power, and then I'll have 1.5. And so my answer for x is going to equal about 2.83, I think is rounded to the nearest. Did they tell us how many? You have to be careful on your next ones on how you round. So what that means is that, oh, that's days. There we go. So it says, how many days do half the students recall the information? Well, they're saying about almost 3 days, 2.8 days. Now it says, after how many days do all of the students have forgotten the important features of the classroom function? So again, my function is going to be P of X is equal to 95 minus 30 log base 2 of x. And in this case, P of x, because all of the students are going to be gone, that's going to be then 0. I mean, every one of the students are going to have no recall. So 95 minus 30 log base 2 of x. So the first thing you would do is what? What do you think? Yeah, move the 95 over. So minus 95 from both sides. So it's minus 95 is equal to 30 log base 2 of x. And then I'm going to now divide both sides by 30. Negative 30, sorry. So I have then, I'm just going to go 5 divided by 30 because I know that those will cancel. The negatives cancel, the negatives cancel. I have 3.16, and then the repeats, is equal to log base 2 of x. Now I'm going to go ahead and change it from my logarithm form to my exponential form. So I'm going to start off with 2. Remember, this is going to always be the power, so it's 3.167 is equal to x. And so my solution then would be 2. And I have it, I'm going to go caret, I have it already in my calculator, so I'm going to arrow up, select it, and enter. And then my answer then for x would be 8.9, how about 8? We'll just put 8, and that would be days. Questions on that one? Okay, so today we're going to do the exponential growth and decay. And I do like this. I mean, this is probably one of the more practical uses of this chapter. And so when we think about the two different terms, so exponential growth and exponential decay, if you're going to increase, okay, the value, in other words, it's going from this point and it's increasing, then that's going to be a growth. If you're also decaying, then it's going to come down. And what it all comes down to is the value of your power. Like in other words, if k is going to be greater than 0, and you have your function, we're going to use the function for exponential growth and decay, is going to be f of t is equal to a sub ot. A sub ot is always going to be considered your first, what you start with, your initial amount. So initial amount is equal to e to the kt power. Well, if k happens to be greater than 0, you're going to increase. And if k is going to be less than 0, like a fraction, you're going to decrease. So it looks at, says find the projected growth rate, in other words, k, for the country whose population in 2022 was 27.7 million, and in 2050 is projected to be 54.1 million. Use the exponential growth model. A equals a sub ot e to the kt power. So in other words, we're looking for the k here. So I'm just going to kind of highlight that a little bit. And in this case, let's go ahead and identify. So in a sub ot, that's going to be my initial population. So that would have to be the one that we start with. So in 2020, it was 27.7 million. And another amount, so the amount that we have projected to it will be then the 54.1 million. And then your time is going to be how many years or how long it takes you to get to that point. So if we went from 2020 to 2050, our time would actually be how many years? 30. Good. So I'm going to go ahead and substitute those amounts in. So I'm going to start off with, I have 54.1 million. A sub ot is going to change to 27.7 million. I'm going to have e to the k times t power. So t is going to change to 30, so I'll have 30k is my answer here. Now, in order to solve this, isolate your e value. So to do that, I want to divide both sides by 27.7. And thus cancels out. So I have 54.1 divided by 27.7, and so I'm with an amount of 1.95 is equal to e to the 30k. Now to solve, I want to go ahead and I want to take the ln of both sides, because if I can take on the other side, let me go, I write the first one, so I'm going to go the ln of 1.95. If I take the ln of e to the 30k, remember our properties told us that we can take the power and we can move it right out in front. And so whenever if I have the natural log of e, so this is log base e of e, then this is actually can be written as 30k times the ln of e. Well, when these are the same, the ln of e, this is just going to equal 1. So then I have a value for the ln of 95. So I'm going to go ahead and just find that with my calculator. So I have the ln of 1.95. And that's equal to 0.6678. And then because of the fact this is just going to change to 1, I have left then 30 times k. And so to solve for k, I want to divide both sides by 30. I'll take this divided by 30, and so that tells me my k is going to equal 0.0222. My next one. And the next one is going to be a half-life, and this is also going to be one that's going to be a tested item for you when you get down to you'll have one on your test. You'll also have one like on one of these on your final. So half-life means that when I end up with the A is going to be A is going to equal 1/2 of A sub ot. So whatever you start with. So if I happen to start with 100 milligrams, that means I'm going to have half of it as a half-life, so it would be 50 milligrams. So all of it, so the amounts of the half-life won't matter because of the fact if I change this to A and I says that that's going to be 1/2 A sub ot is equal to A sub ot e to the kt power. Well, what happens is if I divide both sides by A sub ot, or my initial amount, no matter what my initial amount is, it's always going to be a half of that. And so you'll always start with 1/2 is equal to e to the kt power if you're dealing with half-life. So this is where you start. And the first one, they said, okay, find the half-life of an isotope whose decay rate is 6.3%. So I'm going to first change that to 0.063 for my value of K. And in this case, it's also going to be, since the K is also going to be negative because I'm decaying. And then use the exponential decay model. So we're going to end up saying that we're going to have 1/2 is equal to e to the K, which is going to be then the negative 0.063 times my time. Now once I have it in this form, and I'm going to solve for t, I'm going to go ahead and take the ln of both sides. So I have the ln of 1/2 is equal to the ln of e to the negative 0.063 t. And then I'm going to, I know that what happens on this side, this power is going to move out in front because it's the power. So I have a negative 0.063 t is equal times the ln of e. And the ln of e, remember, is going to be just 1. Yep, so this is going to change to 1. And then I'm going to actually find the ln of 0.5. Now, you can also do the ln of 1/2. I'm going to change it to the decimal, so just 0.5, and I'm going to hit enter. So then I have a negative 0.693. And that means in the next step, I'm going to divide both sides by my rate, which is negative 0.063. So I'll go ahead and divide by negative 0.006. And so my time then is going to end up being then for t equals 11 years. Now, did you do that? Get that with your calculator? Do you have calculators that have the LN? Does your phone have a calculator? Okay, does that work?
Yeah.
You might go ahead and we'll practice that just a little bit, making sure you put it back in to your, or make sure you can, when we do it, I'll have you work one problem to make sure you're getting the right answers. It says, okay, the next one is the half-life of aspirin in your bloodstream is about 12 hours. Okay, how long will it take for aspirin to decay to a 70% of the original dose? So our first start, when we look at the half-life, if we know that this part is our time, this part is going to be a way that we can solve for the amount of K, because in this case we're given the T. T is going to equal 12 hours, but we're really not given the K because we need to find that. But if we're given that the half-life of an aspirin is 12 hours, that gives me enough information to find my K, because what that's saying is that I'm going to go 1/2 of A sub ot is going to equal A sub ot, which is my initial amount, e to the kt power. And so I know that because I'm looking at half-life, I'm going to cancel these out. And so I'm starting off with 1/2 is equal to e to the kt power. And again, that kind of correlates really well with the problem that we did before. This is kind of when half-life, this is the formula that you're really going to start with. Now, in order to solve, we want to do the ln of both sides. So I have the ln of 1/2 is equal to the ln of e to the k. Now I'm going to go ahead and substitute. In this case, my t is going to change then to the 12 hours. So I have k times 12. my amounts, my powers will be moving out front. And so I have, and I'm going to change it since it's k times 12 to just 12 times k. And then I have then the ln of e, which we've talked about before, that this is going to now change to the value of 1. So I just have 1 times 12 times k, which is not going to affect it. I'm going to go ahead and use my calculator to find the ln of 1/2. So I have the ln of 0.5. And again, it's that negative 0.693. And then in order to find my k, then I need to divide that by 12. So k then is going to equal then a negative 0.0578. How about that? We'll just go 8. So in this case, since k is going to be a negative, we know we're finding a decay. Now, but what they really ask us is for how long will it take, so in other words, you have a new time, for the aspirin to decay to 70% of its original dosage. So instead of the 1/2, we're going to actually say that my next problem will be then 70%, which I'm going to change to 0.7 times A sub ot of my original dosage will equal then A sub ot E to the k, which we now know as negative 0.0578 times my time, which I don't know. Now again, the first thing will happen, just like it did on the half-life, is my A sub ot cancels out. So I'm down to 0.7 is equal to e to the negative 0.0578 t. And now at this point, as I'm trying to find the my exponent, I want to take the ln of both sides. So I have the ln of 0.7 is equal to the ln of e to the negative 0.0578 t. Remember, that's going to come out in front. So that means I have the negative 0.0578 t, the ln of e, which we now know is going to change that to 1, equals the ln of 0.7. So, define it. Let's go ahead and go the ln of 0.7, and you're going to end up with a negative 0.3567, and I'm going to divide then, I'm going to have equals negative 0.0578 t. And so now I'm going to divide those. I'm going to divide both sides by 0.0578 negative, and then I'll have my answer. So I'm going to take that one divided by, and I'm going to arrow up, and so my time is going to be then 6.17 is equal to t, and then that would be then hours. Now I'm going to tell you, if you can arrow up like I did on each one on your division problems and not round, you're going to find it's going to be easier to do homework product. If you down and you've a problem and the actual, say you rounded earlier and the actual you put in a number like 6 point something really close, 1.5, and they took it wrong, please just give me a screenshot of that, and then I'll just give you credit for it. Because what it is the problem when you deal with logarithms, you're dealing with like long decimal places that really do matter. And so be careful if you have to clear it out. If you can't go up and grab it like I can on my calculator, go at least to 3 decimal places, and even then that's maybe not quite enough. Okay. So if it's close, take a screenshot, don't be frustrated, and just go ahead and send it to me and I'll give you credit for it. Does that make sense? Yeah. Okay. Use the exponential growth model, A equals A sub ot e to the kt power, to show that the time that it takes the population to triple is given by t equals the ln of 3 over k. What they're saying is that using this model, if I substitute this in for my t, I have A equals A sub ot e to the k times the ln of 3 over k power. Well, if I'm multiplying these together, that's going to cancel those two out. And so I'm still going to say I'm going to have a sub ot equals the e to the ln of 3. And in this case, if just this part alone, if I have e to the ln of 3, remember when we had the common bases, then that's just equal to 3. And so that's what they're doing, is they're just simplifying that problem by substituting this amount back in. And I'm gonna just give you there's one I think on your homework similar to this, but this is not one that I'm gonna really focus on the test. I'd rather have you know and be able to apply the half-life. So the next problem says the growth model is going to be listed here. So in other words, you have a value of k already given in your formula, describes Mexico's population A in millions and T after T years after 2020. And so in this case, it says what is the growth rate? So on A, the growth rate is going to be the value of K. So it's going to be the 0.0106. And how long will it take to double its population? So just like in the half-life, in this case, we're going to double this population. Here's our a sub ot. In other words, they're going to say how long will it take for it to double it. So in other words, what we're going to do for B, it'd be that it would be the same as 2 times 129.0 is equal to 129.0 e to the 0.0106 t. Well, I know that these are just going to cancel out when I divide them from the first step. So just like on the half-life, if I'm going to double it, that means this value here is just going to be 2. So if you remember, I'm going to flip it over. Remember our half-life, the value that we're ending up was just half because our initial amount canceled out. Well, when I'm doubling it, it's going to be that same thing, it's just going the opposite direction. So I'm going to let this be 2. And I'm going to have e to the 0.0106 t. Now, you're going to do what to both sides? ln of both sides. This is like the redundant. So the ln of 2 is equal to the ln of e to the 0.0106 t. Remember, this part is going to come out in front because it's a power. And then so I have 0.0106 t, and I have the ln of e, which I know is going to change to the value of 1. So then I have the ln of 2, which I'm going to find with my calculator. So the ln of 2 equals, and in this case, I'm going to write it just 6931. And I'm going to use it, I'm going to keep it in my calculator, but I'm going to divide it by the 0.0106. And so I have my t is going to equal then 65.39 years. Questions on that one? Okay. We will work a couple of problems on this one tomorrow. I'm just from your homework. So I'm going to go ahead again, and if